first of all, thank you so much to the Passive House Accelerator team and Monty and Prudence for putting this on. This is such a cool event. I mean, what a weird thing to have 200 Passive House dorks from around the world all together on a call for a couple hours. I mean, what a great thing, what a great opportunity. So first of all, thank you guys for putting this together. I know it's a lot of work, and we really appreciate it. It's an important thing during this kind of time, and it's really, really valuable. And then just thank you for inviting me to come in and talk about some of our projects here. It's super exciting to be here with you guys today. So I'm going to talk just for a few minutes. I'm going to try and keep this to like 10-15 minutes. I'm going to talk about a project that we completed last year called the Candela Lofts. This was a really interesting project for us in our office. This was one of the first of our larger multifamily projects, and it was certainly the first commercial development project. So myself and John Mitchell work in BLDGtyp. We're Passive House consultants. We were partnered on this with Nastasi Architects. We had the great fortune to work with John Nastasi and his team, amazing architects, to work on this, and Bijou partners as well. I think Matt Testa from the developers are here, so hold your hard questions for him and ask him in the after portion here.
Thanks,
So
Ed.
we're the Passive House consultants on this, and happy to share this project with you guys here. So this is the project. It's a commercial infill development in Hoboken, New Jersey, 7 stories, multifamily condominium, commercial development to the PHI classic standard. This was a long project in development. We completed it last year, but it was started in about 2013. So this was a long time coming on this particular one. Very nice project though. It was a really fun one to work on. You see the styling is really contemporary. As I said, John Nastasi and his team did an amazing job on the architecture and the construction management. They were really a great team to work with, a really talented bunch. We've had the privilege to work with John for many years. Really great to work with him and Matt and his whole team there at Bijou Partners as well. So nice project. As I said, a condominium, so for sale, a commercial, speculative development. This was an experiment for, I think, everybody on the team. Nobody was sure if speculative commercial property development to the Passive House standard would fly. It's not really a thing that there's much of in New York, at least. So this was a real experiment. The developers and the architecture team really put themselves out there on this one, and I really commend them for that. So it's a fun project, and like I said, a real experiment. For the geeks, this was to the PHI Classic certification. We started this so long ago that it was actually certified to the old PE certification. If that means anything to you, you'll understand what that means. We met the 15 kilowatt hour per square meter heating demand limit, the 17 for the cooling and dehumidification demand limit, and 102 for the PE demand. So this was so long ago that we didn't even consider the PER, although we would probably do that now if we were working on it. Something like R40 walls, R50 roof, R40 floor for this building in order to get us to that level. The density obviously really helps. That said, there were a lot of challenges on this particular building. Start with the climate. So this is a project in Hoboken, New Jersey, right across the water from Lower Manhattan, a really dense urban neighborhood, and a lot of challenges on the climate front. A place like New York, we have to wrestle with all of our heating demand, heating energy, obviously, cold winters, but also a lot of cooling and a lot of dehumidification. So a real challenge when it came to the systems and the overall building design, a really challenging climate to build in for sure. In addition, it's, as I said, an urban infill project, and it was a really not ideal site in many ways, but that's not really surprising. It's an urban infill project. The site is the site, and it was in many ways pointing the wrong direction from the get-go. So it's a north and east facing property. So we have street front north and east facing. We have a long lot line on the west side, and then not very much exposure on the south side, a neighbor to the south there, a really tight urban neighborhood to be building in. Really, really difficult spot, I think, for sure. So difficult from the engineering side and certainly difficult from the construction side. But again, they did a great job of it. From the outset, one of the main challenges on this one was that the building was, let's call it, compactness challenged. All for good reason. It's contextual zoning and lifted up off the grade for flood reasons, and holding the street front and zoning, and there's all sorts of reasons why the building is the way it is. But anybody who knows what a passive house looks like, that a passive house prioritizes compactness, and that's not a very compact building. We were completely exposed on the underside because of the parkade, because we were lifted up off the ground. Again, all for good reason, all with completely good reasons, but very challenging from an overall massing and shape form perspective for sure. In fact, I think I counted this the other day. We were up to 14 corners per floor. I'm not certain, but I think there's got to be some sort of AIA award for number of corners per floor. I hope John Nastasi's on the call here. Good-natured ribbing there. You know, obviously a nice project, but very challenging, again, from a compactness and a construction standpoint there, for sure. But really, the biggest challenge on this building, the main thing that we were struggling against from the very beginning, was exactly how this building was built. As I said, it's commercial property development in the New York metro region. It's built from steel stud, concrete floor slab, gypsum siding, or gypsum sheathing. It's built in a really challenging climate under really difficult conditions, a dense, narrow lot. This was a very difficult project to manage, as I've said many times now. So how did we do it? How did it get put together? Well, overall, or I guess I should just say overall, in fact, what we found when we crunched the numbers was that the thermal bridge losses alone on this building, because of the way it was built, because of the steel studs and the concrete and the footings and the parapets and everything else, were responsible for probably like a 10% increase in overall heat loss. That's after we worked really hard to optimize and improve and manage, make sure that we had all our surface temperatures in the right place and moisture resistance. And so just the nature of the type of construction here, steel stud, concrete floor slab, masonry, makes it very difficult to achieve those traditional passive house limits. So again, how did we do it? Well, this building uses a really simple strategy. We just took the base building, steel stud and concrete floor slab, and we wrapped it in a thick wool jacket or a thick wool sweater. That's all we did. There's really no more magic than that. In this case, it happened to be about 8 inches of mineral wool that we wrapped the entire building in as a thick sweater. Here we used low conductivity facade clips made from fiberglass material so that we get very low thermal bridging through that. And you can see we hold those steel Z girts out away from the facade. It allows us to get that continuous 8 inches of mineral wool surrounding the entire building. It gives us something like an R40 wall on this project. You can see the building under construction here. There's a photo from Nastasi Architects as well. During construction, you see the depth or how far back those windows are set. That's the thickness of that continuous exterior insulation. You see the vertical girts over the outside of the insulation, and then the horizontals there, which are going to support the facade. So that greenish material there is that mineral wool insulation. Here's another photo of the construction. This is during construction. You can see the 2 layers of 4-inch mineral wool being installed there, and the clips, those fiberglass facade clips. So those, again, really help us to ensure low levels of thermal bridging, give us that continuous envelope or continuous layer of insulation around the entire building. You can see the detail on the right there, how the building was put together, and that window detail there. So lots of insulation enabled us to meet our heating and cooling targets relatively straightforwardly, even with that difficult backup wall. Now, in terms of the airtightness on the project, we were able to structure things and design the wall in such a way that we could use the weather-resistant barrier as the airtight layer. We found that there was a lot of economy in that. We felt that was a good strategy for a project like this to implement. It would give us the best chance of getting a really good airtightness at a reasonable cost premium. There were some detailing challenges, to be sure. We had to do a little bit of modification when it came to things like window details, door details, and penetrations and the like. Nothing that couldn't be overcome by the construction team, though. And one thing that we did get here, which I really like, is that we got a double seal on those windows. So we actually got 2 layers of airtightness, an exterior seal and an interior seal. For the folks who like 2-dimensional drawings, here's a section detail of that window. So here's where the window, here's a head detail of a typical window install. And those of you on the call who are passive house dorks are probably yelling at me right now saying, Ed, that window's in the wrong place. Any of you who have ever gone through any of our passive house classes know that we stress put the window out in the insulation layer. That's how you're gonna get the best performance. Well, not on this particular one. Not that we wouldn't have gotten better performance, just that there were lots of reasons having to do with waterproofing and structure that we couldn't put that window out in the insulation layer. So we do the best we can. We overlap it with insulation over the face of the window. We're still able to get a very low psi install value. For those of you who are interested in such numbers, about 0.04 for the heads and jambs on this particular one. We can see we have very good FRSI values as well. So even with the window in a slightly wrong place, we're still getting very good condensation resistance, good thermal comfort, high surface temperatures, and low thermal bridging at those edges there. So even though it's not perfect, it still gets us in a good place. And I like to show this because there's actually a good detail here that I like to show. Um, this was a detail that the cladding team came up with, the cladding manufacturers came up with, John's team and the cladding installer. And I like it very much because one of the things that we often struggle with is how to detail these deeply inset windows. You know, how do you actually attach trim? How do you like physically build a thing like this where you've got 8 inches of continuous exterior? And I like this detail because they were able to figure out a way to attach a back span. So they've got like a little metal angle there, and it's not fastened to the building. It's fastened out at the Z-girts, the vertical and horizontal Z-girts, and then cantilevers back towards the building. Notice it never touches the building, allows us to get good continuous insulation over the face of the window with no thermal bridging, allows the team to install all their trim all the way around in a really reasonable way. I thought it was a really successful detail. And again, this was the cladding manufacturer, installers, and architects team came up with this one. It was a great detail. Worked awesome for us in the end there. These are just some photos of the air tightness going in. I think it's important to stress that this was actually during a mock-up for the window. So one of the things we did with this team was a lot of on-site education and review, inspections. This was during a whole window install mock-up where we had the whole installer team as well as the architecture team and our Passive House team there on site, working through ideas and methods for installing windows. You know, there's a million ways to skin the cat, and we sort of had to work with them very carefully to figure out the best, most buildable, most cost-effective way to install these windows in a way that the installer teams were comfortable with, were happy with, enjoyed, and gave us the performance that we wanted out of this project. You can see here the final install of the building. As I said, we get 2 layers of air tightness on these particular windows. So you can see in the exterior photo on the left, the sort of goop-based seal on the outside. So we have a really high quality weather resistive barrier with a sealant. As you could imagine from the way that I just described that, I'm not a huge fan of goop-based seals, but that's partly just because I'm really clumsy on the job site. So that goop ends up on my elbow, and then it's on the truck window, and then it's in my hair, and then it's all over the house. And, you know, I personally prefer those air seal tapes, but that's just me. We work with a lot of teams who are perfectly good with the goop-based stuff, and gives you a good weatherproof seal on the outside. That's as per warranty. We're not going to make them do anything different there. And then on the right-hand side, you can see we were able to get that supplemental air seal taping on the inside to make ourselves comfortable. That gives us a really nice, flexible, long-term air barrier. It's going to be resistant to windows slamming and people hanging off the windows and baseballs getting thrown against the windows, you know, the things that happen to buildings, right? So we got 2 lines of air sealing there, 2 lines of air sealing, which we were really happy with. And then just lastly here, last couple minutes, I just want to show some of the thermal bridge mitigation efforts that we undertook here. Just especially if you haven't seen a type of building like this, using a concrete steel structure to build a building like this to this level of performance. You do have to do a little bit of detailing, which might be quite non-standards, things you haven't seen before. So for instance, the concrete balconies are one place where we really struggled with the thermal bridging issues, both in terms of heat loss, but especially in terms of surface temperatures, mold and moisture resistance. We were able to find a product, and the team was able to successfully install a product which gave us a structural thermal break at those concrete slab balconies. So we still get the architectural benefit and the urban benefit of those exterior spaces on the building, but we get the full thermal break at those balconies. What does that look like in practice? It looks roughly like this. So here's a couple photos from the job site under construction, and you can see those slab edge thermal breaks as they're installed. These get cast in place during the forming of the floor. So as the building is installed, these things is formed, these things get laid in place, the concrete gets poured around them. There's stainless steel rebar that connects to the mat on either side. Again, gives you the benefit of those cantilevered balconies, but with a thermal break. It's not perfect, but boy, it sure makes all the difference when it comes to surface temperatures, mold and moisture resistance, as well as heat loss. This is a photo that I took from standing on that balcony. And when the building was mostly complete, it's an infrared image, obviously, showing red or yellow being warm, blue or dark black being cold. And I'm standing outside on the cold balcony in the wintertime. I open the door, it's nice and warm inside, the building's almost done. And you can see the remarkable effectiveness of that slab edge or balcony edge thermal break. There is very little heat flow flowing through that concrete slab out into the balcony. So a good example of exactly how these things are working in practice. Build the building like a thermos. All the energy that's in stays in. And then just lastly, one detail that I really want to bring up because it was a real head scratcher for us. And so I think maybe other teams might struggle with it. So I just want to share it here. Was the party wall. We had a small chunk up against a neighbor. It was big enough to let a bunch of cold air in, but not big enough to actually put a human in there to build something properly. Just a 6 or 8 inch gap up against the neighbor. Of course, that's very typical for a lot of projects. And this was a real head scratcher for us. We were not sure how to deal with this for the longest time. We sort of iterated through a bunch of different solutions before finally settling on a slab edge product, very similar to those cantilevered balcony thermal breaks, except this one's one-sided. So it actually allowed us to get our thermal isolation up against the neighboring building. And then the design team came up with a solution to build the walls from the inside out. So the installers and John Anastasi's team worked really hard on site to figure out a way to put these walls together, laying down on the ground, and then build the wall from the inside out using a CH stud that allowed them to get both an air seal and a thermal break at the edge without actually having to work from the outside of the building. It was a challenging one, to be sure. It was a weird one that we hadn't run into before, but a totally common one when it comes to urban projects. So I'm sure we'll use this detail again in the future. So with that, again, thank you so much for attending, and I hope I didn't go over too long, and I'd be more than happy to take anyone's questions, obviously, and discuss the project. Happy to answer any questions you might have. As I said, I think Matt Testa is here as well, so he can answer the hard questions.